Welcome to this session on emerging technologies in the global context. We're assuming everyone who is coming, we're a minute or so in advance, who is coming remotely is beginning to be logged in and hopefully can see the speakers for our first section. And of course the audience is beginning to fill out in this rather large room. So we very much enjoy your participation. Gretchen Stahlman, who is this person here, Gretchen, and I, it's all right, I'm just going to say have organised this session. So we will be playing a tag team throughout the presentation, or throughout the session. Gretchen is also talking on a couple of occasions, and that's why she's sitting there, and I'm standing here, because, so she can't be the organiser team at the moment. So we've been organising the session, but also...
Oh, yes. Sorry, I couldn't hear you very well. I can hear Alison.
Greg, can you hear us now? Okay.
I hear you.
Great.
Yes.
Greg, that was Greg Mora. You can correct me, Greg, with your last name. That was Greg from Albuquerque in New Mexico, USA, who is one of the organisers of this session, along with Siddeswara Guru, who's sitting here in the room and will speak later, and Shelley Stahl, who is also sitting in the room. So Gretchen and I are talking on behalf of the organising team. We've got a fairly tight schedule, so we'll try to keep to time. But before we start, we'd like to acknowledge and celebrate the first Australians on whose traditional lands we meet. Some of you will know from attendees here that Brisbane is in the lands of the Turrbal and Jagera people and is called a place called Meanjin. And we pay our respect to their elders, past and present. And I can see we started a little early, so welcome to all the people who are just beginning to come in the room, and apologies for our quick start. Okay, so we've got 90 minutes here, and it's organised in a series of panels with which, and this was what you were going to say. There we go.
Hi.
Sorry.
Welcome everybody. We're so glad you're here, and we hope that this will be a really interesting brainstorming session. In order to facilitate that, we have it structured around a series of questions and panel discussions, followed by Q&A from the audience, and then a fulsome discussion at the end of the session where we might synthesize all of these ideas. But we're also, here is a link to our collaborative notes. You can access the QR code or the short link. So please do that, because we'd like you all to take notes in there as you like, and also record your name and contact information so that we have a record of the session. We also have a collaborative Miro board. I'm not sure if all of you have used Miro, but there are links to the Miro boards in the collaborative notes as well. And we will have QR codes for each Miro board. And this is where you can put sticky notes as you brainstorm. Okay, and these are our panelists. We have a wonderful lineup, and I think everybody will introduce themselves when they speak, so I'm not going to go through everyone one by one.
Not too much. I haven't got time. But anyway, yes.
We have a tight schedule. We are really trying very hard to stay on schedule. So without further ado, these are the questions that we're going to be considering. And each panel, we have 3, will speak to each of these questions separately, and then we can synthesize our perspectives at the end. Here is our agenda. Each panel discussion will last about 15 minutes, followed by approximately 5 minutes of Q&A, and then we will leave 20 minutes at the end. And we're already ahead of schedule. We have 1 minute to spare of our welcome and introduction. And I guess we can get started with the first panel discussion.
Which is why Gretchen, as you can see, who is listed on here, is going to sit down. And we have 4 of our panelists here on talking about this question. So what we did, we were the organisers, who were mentioned on the first slide, brainstormed what sort of questions were relevant in response to the topic of emerging technologies in long-term data sets, etc. And we posed these questions, and then the speakers nominated what they felt they were best able to talk about. So we haven't necessarily got 4 people per question, but these are questions where these people thought that they had some good material to present and some ideas to share with you. So alphabetically, we have Stephen Bird, who's over there, then Hugo, Tavita, and Gretchen. So I will pass over to Stephen if you're ready to talk first, and each person has a few thoughts to provide on the topic, from their perspective.
Thanks, Alison. So this particular question for me, I in my mind broke this up into a couple of different aspects. The data life cycle part, the risk of data loss, and preservation. We'll sort of touch on bits of these. My perspective, so I come from an organisation called QCIF, Queensland Cyber Infrastructure Foundation. So we run large-scale infrastructures in support of research. So I have an infrastructure lens around this particular question. So from a data lifecycle perspective, there's often a balance that you need to strike between performance, cost over the course of the life cycle of data. From collection through to being active, through to being archived, and ultimately through to being deleted. And each of those have got different characteristics that kind of influence what gets brought forward in terms of capabilities in the space. And you start to, even from a data collection perspective, you're starting to deal with data loss, because a lot of environmental data is coming off sensors. And I'm sure many of you have probably got drawers full of SD cards, external hard drives, and all of these things can lead to failures. From an emerging technology perspective, those sensors are getting bigger, higher fidelity, more accuracy, greater precision. So the amount of data that sensors are generating is rapidly increasing. And that's something from a data storage perspective that we need to deal with fairly carefully. That collection tends to need to go into storage that's going to become the primary copy of that data. So it needs to be generally accessible, hopefully fairly close to where that data is being generated. But given that sensors are scattered all over the place, there's often a manual step that needs to go and collect this. And then that primary source of data then needs to be analysed. And this is where you're starting to move into an active state of data storage. And that's going to tend to live on faster access storage, might be coupled with compute environments, whether that's cloud computing or high performance computing. They've got very different storage characteristics that sit inside of that space. And if you're not careful, you can end up with data being automatically removed if it's sitting on scratch for too long. So you need to be conscious of what sort of policies are sitting around that storage, just to prevent unexpected data loss in those spaces. You then move to your archiving storage, and this is going to be something that is tended to be cold storage, typically tape, but not all infrastructures are going to use tape for this, but it's certainly most effective and most cost-effective storage. And then we come to deletion. Deletion off disk is quite simple, but deletion off tape, not quite so simple. And you've got this concept of soft delete and hard delete. Soft delete states for files can mean that they still sit on tape for 6 months, 12 months before they actually end up being overwritten. So if you're needing assurances that data is being removed, that's very difficult to do in the tape world. Now the emerging technologies in this area tend to be more around movement of data, so network speeds, and density of media. And you probably see that with even sensors in terms of the size of cameras that are being produced, the size of the SD cards that you're putting into all of your external devices. And from a storage perspective, this is kind of replicated in disk storage and tape densities. And we see, disks these days, sort of in the 36 terabyte range, tapes 50 terabyte range. And from a data storage perspective, this scares me a little bit because that's a huge failure domain if you have a media failure. So that creates some challenges with respect to how you deal with those things. Data loss, kind of, you start to create some decisions there around, what are you protecting against, whether this is failure of media or human error, and human error being obviously deletion. And there are different techniques and mechanisms that you bring into play there, and some of these are going to influence. Sorry?
That's okay. We probably better move on to Will, who I think might be able to contribute, pick up a bit on what you've just said. So,
Yeah, thanks very much. I'm Hugo from Dans in the Netherlands. We operate 5 long-term data archives and repositories. Yeah, so 2 somewhat different perspectives maybe to stimulate discussion later on. The first is that one of the most important emerging technologies from our perspective, of course, is AI. And not because it is new, but because it's become easy to use. So it was possible years ago already to do the things we want to do by way of machine learning and automation, but it wasn't simple to do, and now it is. Now, this has implications for how we manage long-term preservation, because we know, for instance, in a long-standing repository environment, 30 years plus, that some of our legacy deposits don't have appropriate licenses, that are not compliant with current legislation. They may not have benefited from vocabularies and definitions of variables that are available now, but we haven't had opportunity to reappraise them in the past. So this, for me, is a huge growth area, is this whole business of reappraisal and format and bit level preservation that will see significant automation, I think, and improvement as a result in the next few years. But this high level of automation has unintended consequences to the extent that there is now widespread abuse of, for instance, robots.txt by AI data harvesting enterprises in the world. Sometimes to the extent that it is almost equivalent to denial of service, where these AI companies are harvesting data from our servers from thousands and thousands of IP addresses continuously. So this is something that needs attention. And on top of that, of course, we are seeing increased automation of a, let's say, more legitimate source, and that is automated research workflows that want to access data at scale and very often and frequently in an automated way. So we need a bit of work, I think, to understand how we are going to structure our services to provide for these legitimate automation workflows, and how that relates to data that is potentially in less accessible storage, because then it becomes an asynchronous process to retrieve from tape and make it available to these automated processes. So there's a lot of nuance there in terms of the demands of emerging technology on our long-term preservation infrastructure and how we operate it.
Gretchen.
Okay, and tell me when I'm getting too close to time, please. So I'm not a long-term data manager. I am an assistant professor at Florida State University. I'm a researcher and an educator, and I study what researchers do with data and how they build evidence and knowledge. So my thoughts are from these perspectives, not from practical experience. But there are a couple of general points that came to mind when I was thinking about this question based on the research that I've done. So just to build on what we're discussing here, It's tempting to think that AI and emerging technologies will solve problems into the future, like missing or incomplete metadata. But, and this is probably preaching to the choir, but I think we shouldn't get lazy, for lack of a better word, in the present. And we should continue to promote good and conscientious behaviors, invest in training, and develop forward-looking infrastructures and standards. Things are changing so rapidly that we need to not lose sight of all we've learned in the past and accomplished in terms of data management and preservation techniques, standards, governance, and knowledge. I was going to talk a little bit about some of my research in this context, but I think in the interest of time, I'll just skip forward to the second point I wanted to make, which is that data curation and data management challenges, and this is something that's surfaced in my research, the same challenges appear to exist after decades of effort. So we need to be realistic about loss. Despite the promise of emerging technologies, it still comes down to the people and the communities caring about data. So yeah, for another one of my projects, we traced the evolution of certain ways of thinking and managing data over several decades. And one of our main findings is that disciplinary priorities shape strategies. So conversations about long-term data need to be tailored to this context. And that particular project showed, again, that the core themes haven't faded away. We see consistent emphasis on the same problems, metadata, integrating data sets. So if we learn from the past, we can extrapolate that these themes are not going away. There hasn't been a dramatic paradigm shift up until now. Maybe we're in one with AI, but we just need to retain a sense of continuity and a connection with the past and everything that we already know. And just to conclude, another strand of my research has been about affective influences on data management. So this emphasizes the importance of not overlooking the people and the communities and supporting their needs and wishes for keeping data alive over the long term. So I just wanted to lean on the lessons of the past as we move into the future.
Okay, I might give Tavita a bit of an intro. We've been moving through and pushing people to keep to 4 minutes, but we do have a Q&A at the end of this session. So some of the panelists may have some really good things to say that they haven't yet. But we're very pleased to welcome Siddeswara, who has come from the South Pacific Environmental Program, which is a completely different context, as was Gretchen. Her context different from many of the people here at this symposium. So, thank you.
Yeah, talofa and good morning, everyone. Thank you very much for having me on this panel, Alison, and thank you to my panelists who have already set the stage. Like Dr. Alison said, I'm Tavita and I'm from the Secretariat of the Pacific Regional Environment Program. And I'd just like to take a step back, perhaps, just to kind of explain the context in which we work. So we are an environmental organization, an intergovernmental organization that works with our Pacific member states on key environmental issues around climate change, biodiversity, conservation, and waste management. And when I was thinking about this question, I think I was seeing it from a slightly different lens, because the environment that we work in is a bit unique. So, for example, in Niue, in one of the countries that we work with, one of our Pacific members, the total population of the island, of the country, is 1,500 people. Okay, so if you can kind of imagine, like, that's everyone. So the human resource is quite limited. So the person that greets you at the airport might be the same person that is a climatologist, in the Weather Service office. So, when I was thinking about the challenges of, emerging tech, And, the constraints on the ground, one of the big ones is the human resource. Because when you're introducing a new technology, then, that's a new skill set that you have to upskill someone that is there in the ministry or there in the department. So they need the support to ensure that they can utilize this new technology to help them in their work. Otherwise, it's just another burden. One of the other key challenges that we're having in a lot of our countries, in our Pacific member countries, is infrastructure. So another example is in Tuvalu, one of the other countries that we work with and implement our projects in. The highest point above sea level is something like 4.6 meters. So like around, that's not very high at all. So if you think about the offices and where they're located, if you're dealing with severe weather events like cyclones, or it doesn't even have to be a cyclone. It could be like a prolonged period of heavy rain combined with, high tide. And just like that overnight, your data, your office can quite literally be flooded. Okay, so that's kind of where the space that we're working in. So I'm really excited to see a lot of the new emerging tech because it allows us to, do a lot of the heavy lifting and the processing, especially, when it comes to things like remote sensing and satellite imagery and how that can complement existing workflows, and of course AI, because in that context, you can nowadays quickly run a forecasting model and compare it with other models that are available, and that's really helpful when you're one of 2 climatologists on the ground. But yeah, I think that's just my perspective on where the challenges and the benefits fit. Thanks.
Sorry. We have, look, thank you very much to all of the panellists for having put forward such different and complementary but also different perspectives from their context as well as their experience and the day-to-day work they're dealing with. We've got a few minutes for a Q&A and or if the panellists wish to add a little bit, having heard from each other. We have been sharing some of these ideas online before the meeting. But has anyone got any questions from the audience? Unfortunately, seeing my computer's being used and Gretchen's on the stage, we can't look at the Miro boards, but if people have put a post-it note, please put it up and we'll try and look at them at the end and certainly after the meeting. So when you go to the collaborative notes page, this is the link to the Miro board, sorry, pointing at my computer. This is the link to the Miro board for this question, but they are repeated in the collaborative notes page. So please go to the collaborative notes page, and if you can, leave your notes, any comments you have, either in that page or in the Miro boards, and where they will be collated later. So I've said enough. Has that given people enough ideas for questions? But Wim has got an addition.
Yeah, I just want to add another perspective which didn't occur to me until now. But yesterday I heard in one of the sessions this notion that allocating a persistent identifier somehow guarantees persistence. And nothing could be further from the truth. For many situations, the half-life is around 8 to 12 years. So 50% of all persistent identifiers don't resolve anymore after maybe 12 years because the managers that need to maintain the links between the persistent identifiers and the objects that they reference are not probably adequately funded or well enough organized to maintain those links. So I'm talking here specifically about scholarly outputs and data sets, not other PID reference material. Now, the point I want to make is that there is a general expectation that the repository ecosystem of the world will look after these things forever, but there's no money for this. So we have this opportunity now to make a quantum change in our efficiency with AI-supported tools. But after we've mined that possibility, we're going to run out of money again. So there's a structural issue here that open science and the funding community and so on expects this endless availability and persistence of research outputs, but they're not willing to fund it. So I think this is quite an important point.
Right. Thank you very much, panelists from question 1. We are now going to go on to question 2. So please, could we welcome, Stephen can stay there, but I'm afraid we have an online participant, Greg Mora. So in fact, the stage will look a little quieter, but because there'll only be 2 people, Siddeswara Guru from TURN and Stephen Bird from QCEF. So Siddeswara Guru, if you're on the collaborative notes page, so what I will do back here is there's the link to the collaborative notes page. So if you haven't got there, please have another go. And the profile that of each of the speakers or panelists that we whizzed past is there. This particular profile is there. So I'll go back again. Sorry, Brian, and others, if you want to get that collaborative notes page. I don't know whether Stephen needs to duck. Stephen, could you please duck or move the chair? Sorry. Sorry. You can find out more about our illustrious list of panellists who come from all sorts of different backgrounds. So, if we could come back, we're doing question 2. Please come back to the stage, Stephen. Who has some more to say, as of course all of them do. It's really skimming the surface of all of this, and we have some other activities that may help with that, don't we? But we'll announce that at the end. Okay, so question 2, please.
Question
Stephen's
2.
the first cab off the rank.
Again. So this one's, data democratisation.
Sorry.
No, that's all right. All good. And what does it
you
look
might
like?
like to define democratisation.
Ah, wonderful.
Yes, well, just a bit.
So probably most people's response to what does data democratisation mean, probably their first thought is around access to data. Well, it's a little bit more than that, right? Because it's not just access data, there's a skills element here for people to be able to upskill and understand the data that they're looking at. So that's an important aspect to it. And as part of that, there's a governance layer that sits around that, because not all data is equal, not all data can be treated the same. So there's that governance layer that's looking after the security of the data, the accuracy of that data, and there's compliance reasons that need to be taken into account. But if you get data democratization right, there's a whole bunch of benefits to that. So it should help to speed up time to insights. It should help with collaboration. It should help with equity of access and better decision making at the end of the day. Part of the problem here is that, part of the whole solution with respect to data democratization is about breaking down silos. And Wim kind of touched on it with respect to the funding arrangements of these things. So most research institutions, certainly in Australia, I'm not sure about other parts of the world, ultimately are responsible for storing the data that their research projects are about. So the grants that they're receiving aren't funding storage, they're not funding the ability to share that data. And institutions tend to take a very myopic view, in my sense, from an infrastructure perspective, that the data is theirs, and we'll contain it to our researchers and maybe their collaborators, generally to their collaborators. But those data silos are just a natural consequence of not having an enduring national repository or international repository for data sets. The data we're dealing with can be huge, so moving data is a challenge as part of this as well. But because you don't have that enduring national infrastructure, institutions are taking that responsibility. Those institutions sit behind firewalls, they've got their own identities in terms of access, they've got their own licensing that they're applying to the data sets that they're controlling. And as a result, it becomes difficult to share. If you don't have that national repository, then data democratisation really needs to start thinking about how do we federate access to data across multiple identity domains, multiple separate sets of infrastructures. They've got different access capabilities, different latency perspectives, different analysis environments that are connected to these things. So it becomes a challenge in terms of what you need to do from an infrastructure perspective to actually enable data access and the governance layers that sit around that. And this also becomes particularly important for data that involves First Nations people, the care principles that you're probably all familiar with as well. Most of us will store data and metadata about the collections that we're storing, but decisions with respect to care data also need to consider attributes of an individual. So what nation they're part of, what clan they belong to, what gender they belong to, what gender they are, sorry. And those attributes of the individual are matched with attributes about the data to make decisions around who can see what. So while we have repositories for metadata around the data that we collect, there aren't repositories about the attributes of an individual to help make those decisions around who can access what. So I think part of the solution here for democratising data also needs to be building out some of those types of capabilities and solutions as well, and not just the data access elements.
Fantastic. Hand over to Guru.
Thanks, Alison. So I'm Siddeswara, so program lead for the Data Service Analytical Platform. So we are the research infrastructure who works on the terrestrial ecosystem. So when I was a student in a school, so in India, so there was 3 pillars of democracy. One is the executive, legislative, and then the judiciary. That's what we taught in a school. So if you take a data democratization, there are 3 pillars again: data producer, publisher, and data consumer. So basically, it's just like any democracy. If any of these 3 pillars go AY, there is a riots on the street. You can see in Bangladesh that happened. You see in Nepal that happened. There is always a claim that the external people come and exploit that. That's true because there was already a hole. That's why that happened. So unless these 3 pillars, the data producer, consumer, and then the publisher, have got a tandem working relationship, I think that's where the data democratization works. So for example, if you take the data producers, right? So data producers, what they want, okay? So they want a bit of a funding to collect the data. They want a right, basically intellectual property is not exploited. And then what they want is basically they can leverage that data to make their publications. And then even now, the data publication is not a first order asset. Their academic publication is more preferred than the data publication aspect. Okay, so that is a bit of a challenge. And then there is an accusation from the data publishers, data producers that they hoard the data, partly because to do some research on the data and publish, probably they don't have skill set to publish that data and then even the analyze and send it to people like Steven, who runs the data center. Okay, that is the issue. Because a lot of especially from the Australian context, if I put an application for the ARC application, right, I never put any budget for the data management. But it takes around 15 to 20% of your budget to do the data management when you collect the data. Okay, that is the perspective from the data producer. If you take the data publishers, a lot of the data publisher repository, they have like a one way to look at the data. There is no customized way. And then there may be a one license, okay, for example. In turn, we say that by default is CC BY license. There are a lot of international repositories which say it's a CC0 license. For example, in Australia, CC0 is not even supported because you cannot forfeit the moral rights. Okay, so whereas in US, there is CC0 is normal. Okay, so these are the challenge. If I want to publish anything in the US repository, for example, then CC0, it is not even holds good under Australian law. So that is a challenge. Okay, so how are we interact with this kind of an issue? And if you take a data consumer, okay, so a lot of often, even in our repository, we provide, look, you need to cite this data. How often people cite the data? They cite their papers, but the data, they just put it in a footnote or in a text. Oh, we use turn data. But they never mention in a reference how they are cite the data. So basically, as a consumer, they are using the reference, and then nobody knows that how that data is used, and then that is not auditable. And then the data basically producers may think that they are robbed a bit of a thing. So unless each one of them knows what they need to do so that it works in tandem, so that's when the data democratization can work in harmony in this environment.
Oh. Coming from Turn, that was good, very good. It's a good advocacy. Now we are going to be joined by our third speaker from Albuquerque, New Mexico, who will come on screen in a minute, who also nominated this topic. Hi, Greg, how are you? I hope you can hear, and I think this microphone will be off. You have around 5 minutes.
Yes. Hello, everyone. Can you hear me okay?
Yes.
Okay, good. Yes, hi, I'm Greg Maurer. I am a data manager with the US LTER network, and also I'm one of the investigators at the Environmental Data Initiative, which is the research data repository that most directly serves the US LTER network. And so yeah, I think the two panelists just before me hit on some really important points, and I'd like to maybe follow up with just a couple extra thoughts here. So democratization of data, like democratic government itself, is real complicated for a few reasons. First of all, I think that the concept of democracy as a form of government is really practiced mainly in particular nation states. Yet when we look at environmental data, the value and the utility of that data is often global in scale, or it transcends national boundaries or political boundaries in some way. And so we have to figure out ways to govern that data that also transcend political and national boundaries. So second, that term democratization of data implies that the governance system that we create for our data, our environmental data, will serve the greater good somehow, and will benefit all people somehow. But it really is hard to determine who decides what the greater good is and who the people that are going to gain that benefit from the data are. So democratic governments always or usually implement concepts of majority rule and minority rights, and so we have to be thoughtful about these same kinds of concepts when it comes to managing data as well. And then third, we really don't have fully developed democratic systems in place for data yet. We don't really vote for data, although we do cite it. But even that is a relatively new practice that I don't think is as widespread as we really want it to be. So we also publish our data in really centralized repositories, or commonly they're very centralized repositories. These are not necessarily chosen by the people that use the data. They're funded by a government or an agency. And so we're not even really sure what legal frameworks those repositories or the data they contain exist under, and whether those apply across those national or state boundaries. So I think that democratizing data should really aim for openness and for benefit to the community, but perhaps more in the sense of providing transparency about the source of the data. So really making sure we take care to implement concepts like data provenance, and then clarity about the intent of the data creators and the rights of the data users. So we need to make sure that we're communicating, with the data that we publish. What are the ownership, or who has ownership, who has rights to the data, sort of what are the licensing frameworks that data is published under. And so we know that with the arrival of things like the care principles and frameworks like it, that we really need more than just an open data philosophy to come up with something that is fair and democratic for data. So the communities that create data should have some right to control that data and make sure that it's accessed the way that they agree with and will benefit from. So I think that truly democratizing data and its access is going to take significant investment from many parties, so governments, the community of environmental scientists, lots of stakeholder communities, and data creator communities. It isn't really an easy task to make any piece of data accessible to everyone that might wish to use it, and to also satisfy the desires of the data creators, or the needs for control or benefit or accessibility that data creators want. And I'll stop there.
I think this, thank you, Greg. This is excellent timing, because that was about it. And now we have a few minutes, 5 minutes opportunity. We're sticking to time pretty well. For Q&A, if anyone in the audience happens to have some questions, or any one of these three speakers would like to add a little bit to their talk in the light of what has been mentioned by others and earlier. So you might see there's a few themes coming up. Everyone needs to be involved, basically. That's a good start. I might mention that the LTR network in the USA that Greg Mora comes from, is one of the longest term sustained long-term data collections that has been made available systematically over some time. So Greg's comments come from that sort of from knowledge of that sort of background. Quite a few of the others, like Turn 2010, relatively young compared to the LTR in the USA. Now, other LTRs around the world exist, but stagger from one point to another, and funding comes into it. So rather than me talking, or maybe Gretchen, anyone got any questions? We've stunned everyone with our brilliance, is that right? Nope, okay. Would you like to add anything? Oh, we have a question. There we are, Wim. Great.
Stay there. Thanks. So I think one of the aspects that we've come across that needs attention is that licensing, which is sort of central to this democratization and proper citation and attribution situation. Licensing only addresses copyright. It doesn't address the rights of the subjects or the rights of the, let's say, the researcher, if they are not the copyright holder, and so on. So for publicly funded research, the general trend is to say the copyright has been waived in one way or another because it's publicly available for reuse under certain conditions or provisions or limitations. But the current crop of licenses that we have don't take proper account of limitations that are imposed, for instance, by subject rights. So I think a part of the solution, at least, is in a deep technical sense, that we need to improve our definition and the clarity by which we define these rights that are available to the subjects and the owners of the outputs.
Could you say who you are?
Yeah. David Meditsky, Scott, Bioeconomy Science Institute, New Zealand. Okay, I've got a comment and a question. The comment is, don't forget there are organisations that have to operate under the Public Records Act that can't delete data. So we have our data growth problem is an even bigger way than some of the situations you described. However, let's say that you can actually delete data and you've got a certain amount of resources for curating data. The conversations we've started having is, well, you can't curate everything. So how do you make a decision about what you keep and what you don't keep from a piece of research or a program of research? What's the dimensions that one should be considering of making decisions about retention?
Yeah, quick comment on that. From a repository perspective and a science perspective, then the minimum set that you must keep from a scientific reproducibility point of view would be data sets that have already been cited. Those you cannot delete. And then, of course, there's the notion of not being able to ever reproduce those observations again that overlays it, and so on and so on. But at the absolute minimum, you cannot delete things that have been cited before.
Yeah, and I would just add from our perspective, this is at the Environmental Data Initiative repository, not every data set gets cited. That's certainly that would be sort of our benchmark for a data set that we would keep, but we also try to track what gets used. So what's being downloaded and what do we know that scientists or managers or other stakeholders actually use.
Yeah, so I think the data retention is it's more as a legislative thing as well. For example, take the Australia and the ARC mandate everybody to keep for 8 years the data, whatever they collected. After 8 years, they can discard that. And whereas if you look at the environmental science, if you ask like a Department of Environment, they said, look, unless I have 40 years worth of data, I can't do any policy making with the data because I need at least 2-3 data points with any extreme events, so that nobody can do any litigation on that one. So if you do the maths, then if you look at the environmental science, definitely whatever we collect, we can't delete them. Having said that, I think there's a poster where there's in Australia, there are about 600 terabytes of data in the university sector sitting there, petabytes, sorry. Even UQ has got about 30 petabytes of data. Steve can provide fit of a thing. So that is the biggest challenge in the university sector, facing, okay, what to remove. We can't keep on keeping all these data sets. Somebody has to pay, but what to keep? Steve can.
Only a second, because we're moving on to the next session. Okay, but now that was a brilliant exposition of why this session has environmental data in it, because it does present a really, I won't say unique at all, but a particular case where, look, I can't tell anything because of the vagaries, let alone climate change, the vagaries of climate over 100 years. Oh, there was a flood 100 years ago recorded by the Indigenous community. Yes, it has happened before. It isn't, that's normal, let alone climate change on top. So, yeah, anyway. I'm now going to pass on for question 3 to... yes, we can't quite follow that topic. We're getting really hot there. We'll tell you where we could go later on to have further discussions. But for question 3, which you can see here, Greg will stay. But please, Wim and Shelley, Stahl and Tavita, please join the others on the platform. This will be quite swift because it's a big panel, but we shall manage.
How can we put the slide on the screen so that people can get to the mural?
Oh, yes. Do you have you done the calculation? 3 minutes, and then I'll do this with the timer.
Okay, so question 3 is how can we ensure that our environmental data management practices remain sustainable, both environmentally and ethically, in a rapidly shifting global context? And this is a large panel, so we'll ask each panelist to please keep their remarks to approximately 3 minutes. And we're going to run a tight ship here. So, Guru, you are the first one.
Okay, the sustainability scene I would consider more from a different perspective. So you can consider sustainability from a funding, and then the social, and then the technical perspective. So funding is a critical thing. I think the Wim mentioned this in the question 1, that with the volume of data what we have, if we don't have enough funding, then so we need to take shortcut, and then there is always some issue with the reusability aspect, with the processing, with the evolution of the technology, everything. That is a bit of an issue. And the technology side of the things, I think we should be a bit pragmatic as well. It's not that it is not like a bottomless pit where that we keep on getting the funding. So there is always some innovation should be there, so that we build a better data system, better architecture, and then how we scale that, how we optimally use the infrastructure, kind of a thing. So that is a bit of a biggest challenge. I think somebody mentioned, I think alluded to in the Q1 as well. So that is where the innovation aspect side of the things will come into picture. And then the social thing is, again, it's the engagement between the 3 pillars I talked about. Because it's the end of the day, it's the stakeholders. Basically the stakeholders' requirement evolves as well. So you need to meet those requirements, and then how we optimize that loop of the taking a feedback and make that available to each of the stakeholders. That is a bit critical as well. So I will stop there.
Thanks. So again, maybe a bit of a different perspective. Long-term availability of data sets are sort of guaranteed if repositories are certified as trustworthy. So the World Data System repositories, for instance, need to be certified by Core Trust Seal. And part of the sustainability aspects that they need to be certified on is called a continuity plan. And all of them have continuity plans that says, if I stop functioning, my data holdings and infrastructure can be transferred to repository C. But nobody ever tests this, right? So we've discovered that this is all just pie in the sky, because in some cases it takes 5 years to transfer a large volume of data sets between repositories. So this is a fatal aspect, I think, of the long-term continuity planning for trustworthy repositories, is that those continuity plans are not practically feasible. So we need a different way of ensuring continued access to these data sets should a repository for some or other reason not be able to continue. And that is not a figment of our imagination, because there are European repositories at this current time quietly busy transferring large volumes of data from US-based repositories that have run out of funding.
Greg.
Go ahead, Greg.
Okay, thanks. Yeah, so I would say that I think one thing, from the US perspective, one thing we've learned in the last several months has been that, repositories and the research networks that commit data into those repositories tend to be dependent on federally allocated funding or government allocated funding. And so we now know in the US very well that these commitments can waver. So really cultivating a broader network of support for data producers and for the repositories that provide access to that data is really important. And so that's what repositories in the US are really working hard on right now. We're trying to identify and connect with entities that will dedicate resources to all these vital environmental data streams for the long term. So that can include communities of stakeholders, the management agencies, private foundations, public interest groups, along with the environmental scientists and data managers and government agencies themselves. The other thing we need to do is communicate to those stakeholders and potential supporters just how vital our environmental data sets are and what the risks they are exposed to are. So recently, the Earth Science Information Partners, which is largely US-based organization around environmental data, did an exercise nominating high-value data sets for preservation, so things like the Keeling curve or the Argo float network. And I think communicating what is a high-value data set is really important for scientists and repositories to do right now, and I'd like to see that writ large across the globe and across repositories, just at larger scale. Let's see. And I think in addition to sustainability, so trying to maintain funding, for the long term, I think we need to think about resilience. So the ability to return to full function after a disturbance. So we know there are going to be disturbances to environmental data management and what scientists and repositories can do. And so I think some ideas to encourage resilience would be, we really need to encourage more coalition building or network building among trustworthy repositories. So somebody mentioned that idea that, we can replicate important data sets between repositories. We need to kind of build those relationships where we can do that. And also, like somebody said, test to make sure that it can actually happen. We need to make sure that scientists, repositories, and data managers are participating in the community of international research networks and data organizations. So things like ILTR, RDA, strengthening those networks is really important to ensure resilience. We need to provide more training so that more people know how to manage environmental data well. And we need to make sure that they have the technology. And there's some room for new technologies to make that easier. So, AI agents and better training materials, I think, are things we can provide. And then there are lots of public interest groups, so non-governmental organizations and private foundations that do want to help preserve data. But we need to communicate clearly with those groups, make sure they know how to help and when that help is needed.
Thank you, Greg. I think we'll have to move on, unfortunately, but there will be a lot more time for discussion in the closing of the session. Shelley.
Thank you. Greg, your comments probably could have come right off of the notes of my own page. So foot stomping what you just said and the importance of collaboration with our international friends as we're losing data in the US. So I would add, I think, some connecting the dots. Tavita was talking earlier about the human resources that are necessary to be able to understand the value of data, the use of data. And it occurred to me when Guru was speaking earlier on the 3 pillars, data user being one of those, that sometimes we are not always clear on who exactly are the users of our data. Matter of fact, Greg mentioning that we are having data lost in the US, it's actually drumming up. I think it's fine to say this, panicked conversations by commercial industry who used this free data for validating their models, validating the work that they do, and then identifying themselves as being someone who is really interested in making sure they don't lose those resources. And so I do think it's important for us to understand who our users are. It's not just researchers. It's quite a large group of folks, including when that rain hits high numbers and then the high tide comes in, and exactly what do you do with that, and does everybody know about those sorts of things on the island? I'm sure everybody does. So that's one thing to identify your users. The other one, AI, yes, it's here to stay. And it's also impacting power grids. So when you run those models and you aren't thinking about the power pole you're about to have, I cringe when I say this, because our research of climate is impacting our climate, and that's true. That's true, and so is AI in general. So that is worthy of paying attention to and making sure that we don't take for granted the incredible power that's in these high-performance computing systems, and that we treat that energy as being very precious. And not that I'm not saying at all that you shouldn't be studying climate. Please do. Please study climate. Please don't lose the data. Please keep the data. But we do have to pay attention to the balance. What is necessary versus what is shouldn't. Just don't let your postdoc press the button too many times. Is what I'm saying. You understand. And highlighting Greg's discussion about impactful data sets and the risk framework for repositories. That work, actually, Joseph Gum is out in the audience. He leads that work at the Earth Science Information Partners, and also helps us out at AGU. So just really acknowledging that one good idea from one person can make a huge difference for all of us internationally. So thanks, Joseph.
Tavita?
Yeah, thanks. Really interesting perspectives so far. So from my own perspective, when we're discussing sustainability, I think when you start a new project or initiative, and we've seen this over the years, we'll work with a donor or a partner that has funding that they want to work with us to implement a project on the ground in one of our member countries. So there's a lot of momentum in the beginning, and new funding. Sometimes it comes with strings attached. So sometimes you'll have an established repository that's in place that is quite well known. A lot of people go to it to download or access a specific repository, but you'll have some strings attached, like I said, to the new funding. And so sometimes they'd like something that's more in line, like this is a new thing that was established under this new funding. And so what you end up with in the end is multiple places that host similar or the same data. And so this is one of the challenges that we've been seeing. You have a plethora of data sources where you can access the same data. And I think at SPREP, where I'm a part of, it's an ongoing issue, and a lot of these systems are legacy systems and competing with other newer systems, and what you end up with is like competing funding sources for like a very the same group of users. So you're catering to the same group of users, but now the funding is being split to support different platforms. And one of the ways that we've tried to tackle this is to ensure that the data that you have is providing value. So, for example, I'm the administrator for the Pacific Environment Portal that we look after, that's collating environmental data sets for the Pacific. And the initial use case for the data that you're collecting will be supported if there is a need that it is seeing to. So we have our country ministries. For example, the Ministry of Natural Resources and Environment in Samoa. On a regular basis, they'll need support to carry out a cetacean survey. And that cetacean survey will contribute to the country's State of the Environment report, or we'll work with CSIRO here in Australia, or the Bureau of Meteorology here in Australia, to carry out an assessment survey on the ground that will contribute to a national priority, for example, the National Adaptation Plan. And so when you align the data, towards priorities that, our users expect from us, then there will always be support for the data. And I think that's one of the main lessons that we've learned, is that if there is a high demand for the data, then the support will come easily. So if there is a stakeholder that says, we really need this data from, the meteorological service, because it can help us plan whether we should go fishing, or if, what the next week's going to look like for farming. And when there's a gap, then you're going to have a lot of people and stakeholders complaining. It's like, you provided all this data before, but you can't really say, funding, which is an issue. So that's, a challenge for us, the organizations that are active, the governments and the stakeholders and the partners that are active in the space, to justify to our donors that this is something that we should support. Thanks.
Thank you, everyone. We have a few minutes for questions for this particular panel before we move on to a broader discussion.
Thank you very much for the presentation. I'm Esther Kambule from South Africa. So I think there's much appreciation really for the resources to ensure that there's a sustainability for the data, particularly also for the data producers. But also sustainability is required to access the data. But my question is really, how do we ensure that to access the data, there's also sustainability for accessing the data, because that is also a big issue. I think there's more access for the data that is required by the users. And from the data producers, there's also a concern that refunds or funds are diminishing to be able to sustain, continuously produce the data, archive the data in terms of the infrastructure. But there's also a demand from the users to access the data. So how do we ensure that the sustainability for the accessing of the data? Thank you.
Yeah, so I think the key to this is the usefulness of those data sets to society, answering societal questions. But that is the easy one to address. It's not being done very well at the moment, but if you put your mind to it, it's something that can be solved by plugging the, let's say, research or analysis ready data sets that our ecosystem produces, to match that to decision or policy support ready offerings that the end user community can apply. But the problem is that that only really is feasible for some domains of science. If you're talking about arts and humanities or social sciences, the number of immediate societal questions that can be addressed by the data sets are very small. So that value proposition of convincing society that it's worthwhile to preserve this infrastructure because it supports policy and decision making, that's very difficult to do in some domains. But in the earth and environmental sciences, I think that's the direction to go, is to make ourselves useful and indispensable to the, not the research community, but the wider societal end user community.
So what I'm hearing you say is the sustainability of access. So no matter where that data is located in the world, researchers or decision makers need to have access to that data for their needs. And you run into a number of problems. You run into bandwidth issues. You run into, are you going to be able to get the data that you're looking for? There's a body of information, and can you understand what that is? And do you know that it's trustworthy? And in my mind, I'm layering all of the different challenges of where is it located? Can I trust it? Is it fit for purpose? You know, this is the perfect meeting for that conversation. Do I have the energy to do that? Do I have the bandwidth to do that? Do I have the systems to do that? Is it interoperable and compatible with my tools? And I think you're asking all of those questions. And then is it going to be available next year? And what if they update it? What if they find there was a configuration issue with one of the instruments? And how am I going to know that? And am I going to be made informed of the fact that the copy I have is now dated? And is it going to be maintained? Is it going to be dynamic? I think you're asking everything. Glad you're here at RDA.
One thing I would like to add is that one thing we see at the repository that I am representing, EDI, is that there is increasing commercial use of, what we provide is open data. So large, the commercial AI companies, Google and OpenAI and those types of organizations are taking data from repositories, to use for training and things like that. And so we're trying to figure out how we can put some limits on access to our data so that we can ask for compensation when commercial entities use those data, and that can in turn provide the funding or the support that we need to provide access to researchers and the communities that need open data. So that's one thing that we're kind of looking at as a way to, maybe finance what we need to do to make sure that more people that need to use open data have access to open data, is to try to get some of the big corporate entities to foot the bill for a little bit of that.
I've got a quick question. And it's partly of, and thank you very much, Greg, it's partly of Tavita, and Shelley, both of you brought it up. Having a little bit of experience with trying to connect with researchers in the Pacific Island region, some of which were my ex-students, bandwidth is really quite an amazing problem. And similarly in Africa, with the forestry projects that I've been familiar with, you're there today, there's a cyclone, or the satellite doesn't go across, or something like that. We haven't mentioned that very much, but we mentioned the energy, but also the dependency on communication and accessibility as a result. We can wait for the uploading until the time is good, but when you need the data, you often need, or even to maintain the system. Tavita, do you have any particular insight of practical nature of that?
Yeah, thanks for that question. It comes back to infrastructure. I would like to say, the situation now is much better than it was even a few years ago. With the advent of Starlink and, internet access to some of the most remote areas, it has improved it quite, substantially. So that said, it's still an issue. Some of our partners, for example, they worked in the North Pacific to do some photogrammetry. I think I'm saying that correctly. So there's some, World War II wrecks, ships that are sunken in the Pacific, and there's some environment-related issues. So we were working with them on the coral reef space. The issue was that the package, the output, was something like 24 terabytes, 30 terabytes, and it's not really feasible to, send us a link to download. And in that case, we had to put forward a request to our team, like, this is gonna be a growing problem. Like, we need to have access it, and it needs to be housed here in country, and so we'll have to address it. We could have it, stored remotely, but as a lot of us who work with some of these cloud services, like the bill is going to be crazy for something like that. So we've updated our data management plan to include some of these very high quality data sets that we don't want to lose, that's providing value on our coral reefs. So yeah, the initial step was he actually loaded it onto a hard drive and he physically sent it from the US. So yeah, that's just my experience.
Political reason for asking that question, which is, it strikes me often at RDA or wherever, Siddeswara, not so much Siddeswara perhaps, that the innovation of emerging technologies, for example, which starts 10, 15 years ago with it, and 20, 30 years ago with these amazing new computers, is not shared equally throughout the world. So we had the question about democratisation, which was answered very nicely by Guru, among others. But that availability to even some of the most basic infrastructure, I remember, brings me back 25 years here in Australia, 30 years, but in other places like Tavita. Now we can move on. We might get Stephen to come up here and have a general panel discussion of everybody. So Shelley.
As my colleagues were all speaking, what was occurring to me is there's this, yes, democratization, but also sovereignty. And you hear sovereignty when we're talking about Indigenous data, but it also applies to data about any community. So what does it mean to say that data is mine and I want to store it in country? And I think that's a worthy discussion for us to consider in the sense of ethical and risk mitigation. So, let's take, Brisbane, data about Brisbane. So of course you would want to keep it here, but then perhaps there should be a copy in Perth, and perhaps there should be a copy somewhere else. And we test it. We don't just think it's going to work, but we actually test it because we could, it's fine, it'll stay there, thank you. Because we could be underwater, or we could have a political issue, and these are not maybes, these are truths, and it would be really interesting to talk about sovereignty in this context.
I think that is why there is a lot of the proliferation of data centers in Australia, because every state government and federal government uses the commercial cloud, but there is a pre-requirement that all the data resides in Australia. So that's why you have data center in every city. And then, for example, all our research data is in a Nectar infrastructure. That is, everything is based in Australia. And each of the node, and there's a cloud infrastructure, there's a replica happens. Stephen can talk about that more. So that happens. And then I think, Alison, it's not only about the disadvantaged countries. Sharing data is an issue, big data. So for example, NCI runs the replica of the Copernicus data hub, because you can't keep on pulling the data, that kind of a data, even though you are like a OECD country kind of a thing. So those kind of a thing happens, for example, the replication of the data. And then the same thing with the Landsat, Sentinel, NCI runs that kind of a hub so that the Australians can use that instead of pulling from US, pulling from European Union every time. Everybody has to access that. And for example, from our personal thing, for example, if you look at like a national species list, we generally keep a copy of it, because you never know when we want to access it, that may work or that may slow kind of a thing. We generally keep a copy of that in our local records so that we can run through that whenever we want. I think it is like a universal problem. It's not only focus on particular country, but depending on the size of the data, that is like a universal problem.
I think we're privileged that we can do that. We're very privileged.
Yeah, just to return to a remark that Greg made about having large corporations that are explicitly for profit somehow contribute to the costs. There's an interesting new service called Really Simple Licensing that you may have come across. If not, then go and look for it. It's easy to find. I think the acronym is rsl.org or .com. And what they do is they've combined simple license provisions with some form of authentication integration so that it's easy to share data for free with a researcher, but OpenAI and Google need to pay on a microtransaction basis for data access. So that might be a solution in part.
There are no questions in the chat, but one comment that I'll just share. Early on, this comment came in: I think it is important to aim to build a globally consensus data preservation system. So we're definitely talking about an international context here. Yeah.
So I just want to clarify what someone means when they say preservation, because there's kind of two parts to it. And one, I think most of us tend to think about resilience in terms of protecting against data loss, but preservation is a completely different activity from a data set perspective, in that it's an active process of periodic transformation of data from one format to another. So just wanting to clarify whether, when you're saying preservation, are you talking about that, or are we talking about resilience?
No, we're talking about the latter. So there's a nice project funded in Europe called the Eden Project, and they just now at the end of September published, I think, 16 core preservation processes, CPPs, that involves, amongst other things, aspects such as format preservation, bit level preservation, reappraisal of appropriateness of the licenses, and so on. So it's certainly just, it's a lot more than just having stuff available. It's making sure that it remains usable effectively.
Thanks, Gretchen.
Sure. Okay, what do we do now?
Question.
Yeah.
Robert Shen from MIT University. I have a question for Guru. Of course, always good to see TERN as one of the national important environmental data portals. Do you mind to elaborate on the question about the quality of the data process to preventing garbage in, garbage out, these type of scenarios?
Thanks, Shobin. So I think the quality is depending on the type of data. So the quality control is always a bit of a complex thing. So for example, for the remote sensing data set, there is a different quality control mechanism that was used. So from the L0, from the raw to the L1, L2, L3, depending on how many derived products are come up with the thing. For the human observation, anything, the validation is purely looking at the protocol, whether that meets the requirement of the protocol, kind of a thing. So that is the validation aspect side of the thing. And then for example, the annotation, that's where I was talking about the NSL, National Species List, anything. So that is where we look at the thing. If somebody says that, okay, this is the species, whether that is in the standard list and everything. So that is how we can improve the quality, kind of a thing. So there is no one rules, depending on the type of data set, there is a completely different quality control mechanism that will be done.
Other questions? Thoughts from the panelists? Oh yeah, can we switch to the PowerPoint? Sorry, Greg.
Okay. I think we've, I mean, this is a long session, so I must say thank you very much. Maybe there isn't a chair for Gretchen there. We've got so many panellists, excellent panellists, that have shared their time and expertise and thoughts that we really would like you to make sure you record your notes as well so that we can benefit from that. The session has been recorded, and we shall be listening to that with great attention. So please don't forget to go to that collaborative note page and then go on to the Miro for that. But is that the last? That was the last one, yeah. And then do think of coming. This discussion is quite important. We've given more time so we can be even more exhausted. No, it won't be that bad. And I'm thinking with some examples of commercial use of public data as well, which is quite interesting. So that's added an extra dimension. We have a session on Friday, sponsored by Turn and QSIF. We have 2 representatives here from that, from both of those organisations. It's on Friday, it's free. Unfortunately, you've got to register now, either by emailing me, but we'll have to squeeze you in if you wish to come. But you can come remotely, but do come along and we can continue the discussion. We have three sections with more examples from users, which will really, I think, bring out some of the points made here, but from their perspective. And it's surprising the breadth of use of open data across the board. So we've got that, and we'd like to thank everybody for your participation, particularly, Greg's gone, but he's still there. But it's not a bad time zone for Greg. At many meetings here, there are terrible time zones for people. It's not too bad. You're not at 1 a.m. or something. So thank you very much for every speaker's attention and participation, and also all of your participation in the audience, and keep the discussion going. And we are thinking of a publication, and there are several people in the room who are thinking of publications, so if you are interested in such things, put your name down and we will follow that up. Thank you very much. I think that's it. Thank you.
Thank you, everyone, and thank you for your thoughtful comments in the Miro boards. We'll be looking at that and digesting all of this material, and we hope to have some collaboration here in the audience. And yeah, thank you again.
Thank you.